Beginner's Algebra. This is winter break video number 2 to help you review. We're going to be covering chapter 5 today. Okay. Chapter 5, we will cover such topics as slope, okay, domain and range, okay, and we'll talk about graphing linear equations. And that, of course, will include slope y-intercept form. It'll include standard form, point slope form, and then it'll also include parallel and perpendicular lines. And one other thing it'll include is direct variation, right? Direct variation. Now, I won't spend a lot of time on the real simple stuff. I'll start with slope, which is real simple. Remember that there's a couple different ways to do slope. If I have a graph like this one here, and I want to find the slope of it, the first thing I'll do is I'll find 2 points that I can clearly identify. For example, there's a point there, and then it looks like there's a point there. I'll tell you what, I'll find one more. Yeah, 2 more. Okay. The easiest way would be pick 2 points that are closest to each other and count rise and run. So from point A to point B, I'll label all of them. I will count up rise 1, 2, 3, 4. So my rise number is 4. My run number is 1, 2, 3. Okay, 4/3 is my slope. I will get that if I go B to C or C to D. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. I have to get the same slope. Let's say, though, I didn't see point B and I went A to C. Well, in that case, I'd go 1, 2, 3, 4, 5, 6, 7, 8, and then count to the right 1, 2, 3, 4, 5, 6. So in that case, I'll get a slope of 8, 6, but that simplifies to 4/3. Okay, counting slope should be really simple. Please remember that a line going up to the right will have a positive slope. Up to the right is positive. Down to the right will be a negative slope every time. It's guaranteed. Okay, a horizontal line like that, hopefully you can say it. Go ahead, shout it out. That's a 0 slope, right? 0 slope. Because the rise would be 0 and the run might be 2. 0/2 is the same as 0. A vertical line like this one here would have no slope. Remember, if you can't ski down it or across it, it has no slope. That would have a rise of, say, 2, but a run of 0. You're never allowed to divide by 0. This has no slope, or you could tell me it's undefined. One other way to do slope is if I give you 2 points, say like 5, -12, and, I don't know, -6, -8. Use your equation for slope. M equals y⁴ minus y⁴ over x⁴ minus x⁴. x1, y1, x2, y2, right? And I plug them in. Okay, so y⁴ is going to be -8 minus y⁴, that's -12. It's minus -12. x⁴ is -6 minus x⁴, which is plain old 5. Those cancel. The 2 negatives become a positive. -8 plus 12 is 4. -6 minus 5 is -11. My slope is -4/11. It could be 4 over -11, -4 over 11, or -4/11. They're all the same thing. Okay, so that's enough about slope. Let's quickly talk about domain and range. Remember, the domain are all possible x values, and the range would be all possible y values. In Chapter 5, they give you simplified versions of domain and range. For example, they might give you this: 1, 4, 2, 4, and then 3, 4. And the domain would be something like this. Let me find it. Here we go. My domain would be 1, 2, and 3. My range would be plain old 4. Notice it doesn't repeat. To determine if the relation is a function, I remember for each x, there can be only one y. So I ask myself, where does 1 go? 4. Does it go anyplace else? No, that's a good thing. Where does 2 go? It goes to 4. Does it go anyplace else? Where does 3 go? Does 3 go to 4? Yes, it does. Does it go anyplace else? No. This is a function because those points only go, the x values only go one place. If I have a situation like this, 1, 2, 1, 3, and 1, 4, the domain would be 1. The range would be 2, 3, and 4, right? Okay. Where's 1 going? 1 is going to 2, but it's also going to 3, and it's also going to 4. 1 is going more than one place. That is not good. Anytime you have a member of the domain going to more than one place, you do not have a function. So that's an example of something that's not a function. Okay, briefly I'll talk about direct variation, and it's a little bit out of order. I taught it second, but y equals kx. Remember, for two things to vary directly, if x is increasing, then y is also increasing, okay? Remember that y equals kx looks an awful lot like y equals mx plus b. It's actually the same equation. We might have a situation where we're told that x and y vary directly. We say x equals 5 when y equals 7. Find x when y equals, I don't know, 28. Okay, this is a two-step problem. The first thing I need to do is find k. I'm going to use this information to find k. So I'm going to fill y equals kx, and I'm going to fill in 7 equal to k times 5, and then I will solve for k and get 7/5, or 1 2/5. Then the second part is to use this information and k to find x. So again, I'm using y equals kx. I know that y is 28. I know that k is 7/5. And I need to know x. I'll divide both sides by 7/5. 28 over 1 times 5 over 7. Remember, dividing by a fraction is the same as multiplying by the reciprocal. 7 will go into 7 once, go into 28 4 times. 4 times 5 is 20. So therefore x will equal 20. That is the answer to the question. Okay. If you have a situation where they give you a story problem, you'll want to figure out what the two variables are. For example, the longer you sit in the bathtub, the colder the water gets. In that case, longer is a measure of time. The time is increasing, right? What's happening to the temperature, the other variable? It's getting colder. It's decreasing. This is not an example of direct variation. Okay? The faster I drive, the more miles I cover. So the speed is increasing. The distance, the miles I cover, is also increasing. That would be an example of direct variation. Okay, I know this is a bit of a longer video, but chapter 5 was a long chapter. We were in it for quite a while. Okay, hold on one second. Okay, now we'll talk about graphing. We'll start with everybody's favorite, which is slope y-intercept form. Remember, in the book it only calls slope-intercept form. I love to call it y-intercept form so that you keep it straight. Have a little graph here. Remember, y must be alone for this. Oops, I'm in draw mode accidentally there. See if I can get rid of that. Very good. Okay, I'll give you an equation, say like this. 2y equals 3x minus 5. No, let's make it minus 4, just so it works out pretty. I cannot graph this. Why not? Because it's not in slope y-intercept form. How do I know? The y is not alone. So to get the y alone, I'm going to divide by 2 in all 3 places. Some of you still only divide on, the y and then the 4. We have to distribute the distribution. So y is going to equal 3 over 2x minus 2. All right. If I have a y-intercept of negative 2, remember this is my y-intercept. I'm working from the form y equals mx plus b. B is the beginning, or my y-intercept. I begin with negative 2 on the y-axis. M is my movement, or my slope, and from there I rise 1, 2, 3, and run 2. I rise 1, 2, 3, run 2. And there we go. I'm ready to draw my line. It will end up looking like this. 1, 2, 3, 1, 2, whoop, like that. And of course I need an arrowhead on the end. Okay, that's slope y-intercept form. You guys should be really good at that by now. By the way, how would you graph something like this? So let me change the color here. X equals 3. Now, some of you would be mad. My pre-algebra kids know this exactly. They can do this very well. They figured it out on their own. All they had to do was read the equation once or twice. X equals 3. What's y? I don't know, maybe 1. X has to be 3. What's y? 2. X equals 3. Y? I don't know, maybe it's negative 5. Any one of those will work. I'll plot 3, 1. 1, 2, 3, 1 is right there. 3, 2 would be right there. 3, negative 5, 1, 2, 3, 4, 5 would be right there. I will get a vertical line. Hold on, my boss is calling me. Of course, if I had an equation like y equals a number, my t-table would look very similar, only the x values would change to whatever I wanted, and then the y would stay the same. Okay, so that's slope y-intercept form, and of course, x equals 3 cannot be written in slope y-intercept form because remember, vertical lines have no slope. All right, point slope form, probably the one we use least often, but I know that the Mr. Newman, the honors geometry teacher, one of the honors geometry teachers, um, expects you to know that. He asked me if that's something we teach, and so let's hit that in the video here. I'm sure you'll see it on the midterm. All right, let me see. Let me get this graph here cloned, and I'll bring it on down. Now this is a real easy problem because I automatically know a point and a slope, and if I know a point and a slope, I can go ahead and graph it. My point is going to be negative 1, positive 3. I get my x-coordinate from here, I change the sign. I get my y-coordinate from here, I change the sign. So I will plot the point negative 1, 3, negative 1, 1, 2, 3, right there. Now the slope is sitting right here. Remember, point slope form is a form of the slope equation. That's all it is. It's just if you multiplied both sides by the denominator of the equation you use to find slope when you're given 2 points. So my m is sitting right there. It's negative 2/5. I will go down 1, 2, and I'll go right 1, 2, 3, 4, 5. Down 1, 2, 1, 2, 3, 4, 5 to the right, and there we go. I have a line. Now notice my slope was negative, And I can't remember if it was in this video or an earlier video, I mentioned lines that go down to the right have a negative slope. And sure enough, you see that we are dealing with a negative slope and it is going down to the right. To me, it looks like it's going downhill. All right, so that's point slope form. If I give you a line, say like this, you should be able to write the equation in point slope form. Okay, let's see here. Let's take this line and let me do that. And the properties, and we'll make it stand out in orange. Okay, I can find 2 points on there. Let's see. It looks like that's definitely a point. And it looks like that is also a point, right? Point A, point B. Now, I can use those 2 points to find the slope. So I'll rise 1, 2, 3, 4, 5, and I'll run 2. So my slope is 5 over 2. Okay. When I go to fill it into point slope form, I can pick either point. Tell you what, I'll start with point B. It looks like point B's coordinates are 2, 1. I'll take y, I'll subtract the 1. That will equal 5 over 2 times the quantity of x, and I'll subtract the x value. Had the point been in the negative area, subtracting the x coordinate would turn it positive, hence the signs would change again, right? Okay, now if I had picked the other point, you know what, I'm not going to pick this point, I'll pick that in a minute. Let's say I have this point down here. It looks like its coordinates -2, -9. I could write point slope form of that with y plus 9 equals 5 over 2 times the quantity of x plus 2. All right, there we are. So either one of those is a correct answer because I took a point from the line. Now, if I wanted to write the equation in slope y-intercept form, I could do it 2 ways. I could take one of these equations and convert it, or I could be really, really tricky, really smart, and know that my slope is already 5 over 2, and point A right here is on the y-axis. 1, 2, 3, 4. Looks like it's at -4. So my y-intercept is 0, -4. I could write then y equals 5 over 2x minus 4. If I convert these equations to slope y-intercept form, I should get that unless I have some kind of silly mistake going on. Now I think that's good. All right, so we've done point slope form, we've done slope y-intercept form. The last form is standard, and I got to tell you, I'm really proud of you guys for starting to warm up to standard. A lot of kids like freak out on standard. I don't know, I don't want to do it. But standard form is really easy. Remember, standard form needs to look like this: ax plus by, that equals c, and we always want the a positive. All right? Now, let's say I have an equation like 2x minus 5y equals 10. Okay? To find my x-intercept, I would do c over a. Well, that would equal 10 over 2, or simply 5. 1, 2, 3, 4, 5, right there. Okay, to find my y-intercept, I do c over b, which will be 10 over -5, which will equal -2. Okay, 1, 2, -2. I can then go ahead and draw my line. Now, someone's probably thinking, hey, what about the slope, Mr. Lawrence? Don't worry about it, because I am going to figure out my slope for you. Just a minute. Okay, now my slope could be found by doing -a over b, which in this case would be -2 over -5, which equal 2/5. I must have 2/5 on the brain because I keep coming up with it. I could have plotted one of my intercepts and then counted up to, right, 1, 2, 3, 4, 5, and there I am. 1, 2, 1, 2, 3, 4, 5. And I keep hitting the line, okay? I must not have a very well drawn line. Up to 2, 3, 4, 5. It should be right there. Let me make my line a little bit prettier. Let's see here. It's probably just a little bit of human error. There we go. That's a little bit prettier. And then just to check it so you know I'm not snowing you, let's go down 1, 2, back 1, 2, 3, 4, 5, and there we go. It's just a little hasty there. I should slow down and draw a better line. Okay. So that is standard form. Okay, let me think here. We're already at 20 minutes. Oh, I need to talk about parallel and perpendicular. Remember, the review worksheet I gave you has all these problems on them, so you can test them. They will be different. Okay, for parallel and perpendicular, we'll do them together because they're done very similarly. Let's say I gave you an equation like 3x plus 6y equals 12. And I want two things. I want the parallel line passing through the point, say 4, 2. And then I want the perpendicular line passing through the same point. Okay? All right. So these two lines will be parallel to each other. This one will be perpendicular, and it's really easy to do. Okay, the first thing I need to do is find my slope. So I'm going to find the slope of the original line. Well, using standard form shortcuts, I know I'll get 1/2, actually negative 1/2. The parallel slope will be the same. It'll be negative 1/2. Parallel lines have the same slope. Now, I know x and I know y. I'm going to go to standard form, slope by intercept form, y equals mx plus b. I'm going to plug in m, x, and y and figure out what my new y-intercept needs to equal. Notice I had 4 variables. I plugged in numbers for 3 of them. Now I can solve for the 4th. So I'll go ahead and do that. All right, 2 will equal negative 2 plus b. B will end up equaling 4. So the equational line parallel to the original line will be y equals negative 1/2 x plus 4. All right. Perpendicular is done almost the same way, except I need the perpendicular slope. Well, if the original slope is negative 1/2, I need to take the negative reciprocal of that. Well, that would be 2 over 1. Positive 2 over 1, or simply positive 2. Again, I will use y equals mx plus b. I'll plug in x, I'll plug in y, I'll plug in m. 2 equals 2 times 4 plus b, and I'll solve for b. 2 will equal 8 plus b. b will equal negative 6. All right, my new equation will be y equals 2x minus 6. This one is the parallel equation. This one is the perpendicular equation. And you can always look for problems like that on the review sheet, or perhaps go back. Tell you what, I know this video is running long. I'm going to give you one more situation, and I want you to solve it on your own. Okay, so the original equation is going to be y equals 3/4 x minus 6. I want a parallel line passing through the point 12, 1. And then, of course, I want a perpendicular line passing through the point 12, 1 again. Okay, go ahead and pause. When you unpause, I'll assume you're ready to see my solution. Okay, if you've unpaused, first thing I'm going to do is find my original slope, and that's going to be 3/4. I'm in slope y-intercept form. Now, the parallel slope will also be 3/4. I know that's an x value, that's a y value. I'm going to plug these into the equation y equals mx plus b. So y is 1, m is 3/4, and x is 12, and I'm going to write it as 12 over 1 because I'm going to be multiplying by a fraction. So when I multiply, I think I'm going to get 9 plus b, and then b will equal -8. So the line that is parallel and goes through the point 12, written in slope y-intercept form, will be y equals 3/4 x minus 8. Okay, I'll go over to the perpendicular side. I know my slope was 3/4. My perpendicular slope is the negative reciprocal of that. I'll flip the fraction and change the sign. There's an x value, there's a y value. Plugging them all three into y equals mx plus b, I'll get 1 equals -4/3 times 12 over 1 plus b. 1 equals -16 plus b. B will equal 17. All right, so y will equal -4/3 x plus 17, and there you go. There is the equation perpendicular to the original line. Of course, you can graph all three, and you'll find out that the original line and the blue equation will produce parallel lines. The original equation, that is, and the blue equation. And then this red equation over here will be perpendicular to both the originals. All right, this video was a little bit longer. I don't expect the other ones to be as long as this, but I hope you guys are having a great break. And this is Mr. Lawrence signing off.